Hi everyone, welcome to session 10. So, carbamino compounds via the 23% hemoglobin, the RBCs with the hemoglobin. Hemoglobin is a protein. When it is considered, it is definitely have amine. So, carbon dioxide combined with the amine NH and it results in a carbamino compound. So NH combined with the CO2, that forms one carbamino compound, and another is hemoglobin acidic. So here it is totally hemoglobin CO2 in the sense NHCOO and hemoglobin acidic. This is what we see. That is, this is a carbamino compound and the remaining H combine with the hemoglobin and forms hemoglobin acidic. Hemoglobin acidic. That is, carbon dioxide combined with the NH of the hemoglobin. Basically, the amine is the one to which the carbon dioxide combined. That's what carbamino compound. So NHCOO and hemoglobin acidic. This is how 23% of carbon dioxide transported through carbamino compounds. This is what the second phase of the transport of CO2. The third one is bicarbonates. 70%. So by this what you come to know, majority of most of the CO2 transport by bicarbonates only. And the same equation, that is the role of the carbonic anhydrase. RBC is a cell. Cell will have cytoplasm. Cytoplasm will have the 60 to 70% water. So, carbon dioxide combines with the water in RBC and in presence of carbonic anhydrase, in presence of carbonic anhydrase, carbon dioxide combines with the water and forms H2CO3, carbonic acid. Carbonic acid in RBC is unstable. Unstable in the sense it is not remain as it is, unlike the carbonic acid in the plasma, but here it is unstable. It is not stable. So immediately it breaks down into, it is furtherly forms into H plus HCO3 minus. H plus HCO3 minus. That is CO2 plus H2O in presence of carbonic anhydrase form carbonic acid. In presence of again carbonic anhydrase, it breaks down into H plus and HCO3 minus. What it indicates? It indicates that it is the formation and breakdown of the carbonic acid where the carbonic anhydrase have a role. Carbonic anhydrase is for the formation of carbonic acid and its breakdown. So, anions called bicarbonate ions and hemoglobin, that is the hydrogen ions increased. So, now recall your memory. At tissues, by transport of as the concentration of CO2 is more, so hydrogen ions are also liberated. Is it right or not? So at tissues, CO2 concentration is more and hydrogen ion concentration is more. And generally, this is how the 70% of carbon dioxide is transported. Let's go for the further description. This is the RBC, where the content of the carbonic anhydrase is more in RBC when compared with the plasma. The more the carbonic anhydrase means, the more the formation of carbonic acid or not. Yes. And the more it's breaking down into H plus and HCO3 minus. So in RBC, right at this point of view, the CO2 plus H2O in presence of carbonic anhydrase form H2CO3, which is furtherly break down into H plus and HCO3 minus. In RBC, the potassium cations are present. Okay, and hemoglobin is present. That's the reason why it furtherly forms a potassium bicarbonate, that is electrical neutrality is needed. So potassium bicarbonate and hemoglobin acidic is formed. This is what the formation of the carbonic acid and its further breakdown. So right at this stage in RBC we find potassium bicarbonate and hemoglobin acidic. Now at this stage as more and more carbonic anhydrase is there, more bicarbonate ions are formed. To avoid this state there seen a phenomenon named to be the chloride shift, or Hamburger's phenomenon. That is, due to high content of carbonic anhydrase, the bicarbonate ions go on increasing. As more and more bicarbonate ions are increased, in order to avoid this, there is a mutual exchange of bicarbonate ions to that of the chloride ions. As more and more bicarbonate ions are forming in the RBC. Look at here. RBC. Now, right at this point of view, it is with potassium bicarbonate and hemoglobin acidic. Is it right? Right. Now, in a plasma is with 92% of water and remaining 8% is proteins, organic, inorganic, and even the other gases are also present. The plasma is with the sodium and also chloride, the salts. As more and more bicarbonate ions are formed, the RBC try to exchange the anions present in it to that of the plasma, and in order to bring about the electrical neutrality, it receives the chloride ions also. So now you may raise a question, that is why not it is exchange the cations. RBC have a permeability for anions. Is that bicarbonate ions in the sense anion or not? Yes. Is chloride ions anion or not? Yes. So in this connection, the RBC mutually exchange the bicarbonate ions formed by the breakdown of carbonic acid into H plus and HCO3 minus. So the bicarbonate ions formed in RBC are exchanged to the plasma, and the chloride ions present in the plasma are exchanged into RBC. This process of mutual exchange of bicarbonate ions from RBC into plasma and chloride ions from plasma to RBC is what named to be the chloride shift or Hamburger's phenomenon. The point to remember, that is the reversible reactions. Now in this way, reversible reaction in the sense the reaction which involves the formation of reactants to, that is the left side, a reaction starts at the left side and ends in the right side. Again the reaction what from right side to left side, it shift at one place. At the tissues the carbonic acid is formed. Why? It is that where partial pressure of carbon dioxide is more. The more the partial pressure of a gas, the more its solubility. So at tissues, carbon dioxide partial pressure is more, so oxygen is supplied to the tissues from the hemoglobin. Do you agree? Right. At the same time, at lungs, the partial pressure of oxygen is more. That's the reason why carbon dioxide is removed from the hemoglobin and delivered to the lungs for the elimination. Simultaneously, oxygen combined with the hemoglobin. This is the reason why we consider hemoglobin is a amphiteric compound. Hemoglobin is a tetramer as well as amphiteric compound. What do you mean by amphi? 2. That is, it combined with the oxygen in the regions where oxygen partial pressure is more. Now answer, where do you find the more partial pressure of oxygen? Lungs. Lungs are the region where partial pressure of oxygen is more. So at lungs or respiratory surface region, the oxygen combined with the hemoglobin. And from hemoglobin, the carbon dioxide is removed. So at the region wherever the partial pressure of a gas is more, it combined with the hemoglobin, and the gas whose partial pressure is low is dissociated. So at lungs, from the hemoglobin, carbon dioxide is released out. At the same time, oxygen combined with the hemoglobin. At tissues, the partial pressure of carbon dioxide is more. That's the reason why oxygen removed from the hemoglobin and delivers into the tissues. This is the reason what we name hemoglobin is a amphiteric compound. It associated with the oxygen at the respiratory level, that is oxygen combined with the hemoglobin and liberates the CO2 at the lungs. Oxygen combined with the hemoglobin at lungs, at the same time at the tissues. Carbon dioxide combined with the hemoglobin about 23% and liberates the oxygen. This is why it is an amphiteric compound. And basically RBC, while transporting the carbon dioxide, at this juncture we see potassium bicarbonate and hemoglobin acidic. How? That is, carbon dioxide combined with the water present in the RBC forms the carbonic acid. It is an unstable. In presence of a carbonic anhydrase, it forms the H plus and bicarbonates. And it combined with the potassium, naturally they are the cations present in it, and forms the potassium bicarbonate and hemoglobin acidic. Next, so potassium bicarbonate, hemoglobin acidic in the RBC. In plasma, sodium chloride. Generally it is the general status of the plasma. So in this manner, as the bicarbonate ions are increasing more, as against every bicarbonate ions from RBC that are shifted to the plasma, from plasma chloride ions are shifted into the RBC. This mutual exchange of, as against every bicarbonate ion from RBC, the chloride ions from the plasma are exchanged, which means from RBC bicarbonate shifted to the plasma and chloride ions from plasma shifted to the RBC. This is a chloride shift which takes place at the tissues. Next, so in this way, in RBC, now potassium chloride and hemoglobin acidic is the status. Is it right? In plasma, what do you find? Sodium bicarbonate, right? So is that bicarbonates form, is it transporting more? Yes. In this way, it reaches into the lungs. let's see the condition at lungs. At lungs, partial pressure of oxygen is 104 mmHg. What we discussed, that wherever the partial pressure of a gas is more, the solubility of a gas is more, so combining of a gas with that of the hemoglobin will be more. So at lungs, partial pressure of oxygen is more. So immediately the oxygen combined with the hemoglobin and forms the oxyhemoglobin. Is it right? As the partial pressure of oxygen is more, the partial pressure of a gas more, that is according to oxygen dissociation curve, the more the partial pressure of oxygen, the more the saturation of hemoglobin. As partial pressure of oxygen is more, so saturation of hemoglobin will also be more, means the combining of the oxygen with hemoglobin will be more. So immediately oxyhemoglobin is formed, which means again it retains a saturation of 100% in blood. Now when oxygen combined with the hemoglobin, what are liberated out from RBC? Hemoglobin, when combines with the oxygen, H plus ions are liberated. Is it right or not? Yes. The oxygen combined with the hemoglobin form oxyhemoglobin. So hydrogen ions is liberated. This hydrogen ions combines with the HCO3 minus. The liberated hydrogen ion combined with the HCO3 minus, so forms H2CO3. Look at here, H plus SCO3 minus forms the H2CO3. That's the reason why we say it is a reversible. So combination of H plus and HCO3 minus form the H2CO3. Next, the H2CO3 liberated to form H2O and CO2. So, when H2O and CO2 is formed, CO2 is sent out. So, all the reactions we have seen at the tissues are reversed or not here. That's the reason why the case is said to be the reversible reaction. Even chloride shift is also like the oxygenation of a hemoglobin. Oxygenation as how it is a reversible. Why? The the HbO2 is formed at the lung surface, combining of the oxygen with the hemoglobin of the blood and forms oxyhemoglobin, which is dissociated to form the Hb plus O2. Is it right? Oxygen is unloaded at the tissues. Why? The partial pressure of oxygen is low. Due to CO2 concentration more and H plus ions, CO2 and H plus unload the oxygen from the hemoglobin. That is, the dissociation of oxyhemoglobin is influenced by the CO2 H plus. That's what Bohr effect we have seen. The same thing here. At tissues, at lungs, as the partial pressure of oxygen is more, saturation of hemoglobin will be more, so oxyhemoglobin is formed. So hydrogen ion is separated hydrogen ion combined with the bicarbonates and form H2CO3, and which is furtherly break down into H2O and CO2, so carbon dioxide sent out. So the same thing is repeated, which means at lungs oxyhemoglobin is formed, and at tissues oxyhemoglobin is dissociated. At tissues the carbonic acid is formed, which is dissociated at the lungs, which means formation of oxyhemoglobin at the lungs in blood, combining of oxygen with hemoglobin, oxyhemoglobin, which is dissociated at the tissues, and the carbon dioxide combined with the hemoglobin at the tissues, and again carbon dioxide dissociated at the lungs. This is what reversible reaction. So oxygenation and the chloride shift both are what reversible reactions. So out of the three forms called the physical solution, carbonic compounds, bicarbonates, if I ask you a question, what is the form in which the CO2 mostly transported? None other than the bicarbonates, for which the carbonic anhydrase enzyme what play vital role. It is a catalyst. Sometimes you are asked, that is a question you can be asked, the carbonic anhydrase a catalyst present in plasma only? Second option, it is RBC only. Third option, both RBC and plasma. The answer is none other than both RBC and plasma, but least percentage in a plasma, whereas more in the case of the RBC, which is playing vital role in the formation of the carbonic acid and its immediate breakdown. So the point to remember that most of the carbon dioxide transport by bicarbonates, and here the chloride shift already we discussed. It is nothing but chloride shift, shifting of the chloride, or hamburgers phenomenon. That is the shifting of bicarbonates are go on forming more in the RBC because of the carbonic anhydrase. The more the carbonic anhydrase in the RBC, the more the formation of carbonic acid, and the more it is breaks down. As more and more bicarbonate ions are formed, so as it is having more permeability for anions, RBC tries to send the bicarbonate ions into the plasma simultaneously. It receives. So in as against the every bicarbonate ion transporting into the plasma, it receives the chloride ions. So this is how the potassium chloride in RBC, sodium bicarbonate in plasma, the blood transport the carbon dioxide to the tissues, from tissues towards the lungs. At lungs, the partial pressure of oxygen is more. The more the partial pressure of a gas, the more its solubility, and particularly the hemoglobin saturation would increase. Why? As partial pressure of oxygen is more. The more the partial pressure of oxygen, the more the saturation of hemoglobin. So immediately at the tissues to the lungs, at lungs the partial pressure of oxygen is more. So partial pressure of oxygen is more, PCO2 is low, temperature is low, and pH is more, or low hydrogen ion concentration. Is it right? Right. So at lungs immediately oxyhemoglobin is formed, means saturation of hemoglobin become 100%. At the same time, the hemoglobin acidic was there. At via the blood, the potassium bicarbonate, sodium bicarbonate in plasma, and potassium chloride in the RBC, and in RBC the hemoglobin acidic is there, potassium chloride is there. In plasma, sodium bicarbonate is there. This is what reaching the lungs. At lungs, as partial pressure of oxygen is there, the hemoglobin acidic breaks down and hemoglobin hydrogen are separated and oxyhemoglobin is formed. The liberated hydrogen ion combined with the bicarbonates and results in the formation of H2CO3, which is immediately breaks down H2O and CO2 send out of the lungs, which is what the external respiration. So now as bicarbonates ions are separated, so sodium is without bicarbonate. Generally electrical neutrality is always have to be maintained. That's the reason why the chloride ion present in the RBC shifted to plasma. So again in plasma, sodium chloride is restored, which means at tissues the chloride and plasma shifted to the RBC. What comes back means chloride shift is reversible, which means there are, make a note, reversible reactions are both the oxygenation as well as the chloride shift are reversible. That is, at lungs oxyhemoglobin is formed, is breakdown into the oxygen and hemoglobin separation. Oxygen is unloaded from the hemoglobin. So dissociation, association, forming of the oxyhemoglobin at the lungs in the blood, whereas dissociation of oxyhemoglobin at the tissues. In the same way, the hydrogen ion combined with the hemoglobin and the bicarbonates that are formed, what reaches into the alveoli of lungs, where partial pressure of oxygen is what? More. So hydrogen ion separated from hemoglobin. Why? As partial pressure of oxygen is more, oxygen combined with the hemoglobin liberating the hydrogen ion, which means there are the association of oxygen at the blood of the lungs and its dissociation at the tissues. Next, the carbon dioxide that is formed by combining with the water, it forms into H2CO3 at the tissues, which is again dissociated at the lungs and CO2 send out. This is what we term it as the reversible reaction. So reversible reactions are both oxygenation and the chloride shift. Both are comes under the reversible reactions. Right. So one more point to remember, Bohr's effect we have seen. In the same way, one more is there, Haldane's effect. Haldane's effect. What is Bohr effect? The effect of the CO2 and H plus on oxygen carrying capacity is a Bohr effect. Is it right? At tissues, the carbon dioxide partial pressure is more and H plus is more. That's the reason why oxygen is dissociated from hemoglobin. That is Bohr effect. Effect of CO2 and H plus on unloading the oxygen from hemoglobin. Dissociation of oxygen from hemoglobin. In the same manner, at lungs, the unloading of carbon dioxide due to more partial pressure of oxygen. So these two can be said to be the antagonistic. The effect of oxygen unload the carbon dioxide is what? Haldane effect. The effect of CO2 unload the oxygen is Bohr effect. Bohr effect is influenced by more PCO2, more temperature and more hydrogen ion concentration and less PO2. In the same manner, Haldane effect is more PO2, partial pressure of oxygen is more, unload the carbon dioxide. So these two are what very, very important things to be remembered. So overall, this transport of CO2 in three forms: one, physical solution; 2 carbamino compounds, 3 bicarbonate form. Of all these, 7% is via physical solution. The reason why less amount of the carbon dioxide transported through physical solution, the only reason is if more amount of carbon dioxide transported through plasma, the acidic condition, that is the acidic status, increases, which will be going to be fatal to the human beings. And carbamino compounds, 23% through hemoglobin, carbamino compounds, and 70% is by bicarbonates. The same thing is here H2CO3 formed, here H2CO3 is formed. Carbonic acid formed in the physical solution as well as in the RBC. But why more amount? Here it is an unstable, whereas it is stable. So immediately it breaks down into H plus. As more and more carbonic anhydrous is there, more it is dissociated. So it is immediately breaks down, and it combines with the potassium and it forms the bicarbonate. So immediately it is sent out. So this is all the summary of the CO2 transport by physical solution, carbamino compound and bicarbonate. And these two are very, very important to remember: Bohr effect and the Haldane effect, effect of the CO2 and H plus on the oxygen carrying capacity. And here Haldane effect, effect of O2 on unloading the CO2, that is removal of CO2. These two are what to have. Thank you.